Space has several really interesting properties, but one of them is it's a vacuum. So I can actually use this vacuum pump. I'm going to stop this and get out of the way. I can use this vacuum pump to make sort of like artificial space inside this jar. So I've got this thing called a bell jar, and it's shaped like a bell, even sounds like a bell, right? Okay, so I can put it on this plate, and I can hook the pump up to it, and I can then use it to pull the air out. And then once I've done that, I've made artificial space inside here, at least as far as the vacuum property is concerned. But if I do that, how can I prove to you I've done something? Vacuum is invisible, but so is air. So if I take the air out, how can I prove to you I've done something? Well, I'm going to prove it to you by putting a balloon inside. All right, so just a little water balloon. I'm going to tie it off, and I'm going to put it inside the bell jar. I usually put a static charge on it so it sticks to the top, makes it a little easier to see. Okay, so now if I turn on the vacuum pump, I start pulling the air out. Let's see what happens. Okay, so I'm going to close that valve. Okay, so the pump is on, and as soon as I open this valve, I'm going to start taking the air out. So let's watch. Open the valve, and we'll see it starts to get bigger. Okay, so now I'm going to stop that. So why would the balloon get bigger? Well, what determines the size of the balloon? The balloon has air inside pushing out, right? But it has air around it that pushes back. So the size of the balloon is determined by the balance between the air that's inside pushing out and the air around it pushing back. So if I get rid of some of the air around it, then the balloon can get bigger because it isn't pushing back as hard. Okay, so if I were to let the air back in, what should happen then? It should get smaller, shouldn't it? Okay, so remember, science is always about doing the experiment. We always want to do the experiment to prove our ideas. So let's let the air back in, and look at that. It got smaller just like we expected. So now the question would be, can I make it pop? So let's go ahead and see if we can get it to pop. So again, we're taking away the air around it, and notice it's not very loud when it pops. The reason it's not very loud is because when you study sound, some of you may have already studied sound, when you study sound, you learn that sound requires air to get from the source of the sound to our ears. Well, I got rid of most of the air in there, and so there's not much air to transmit the sound. Now, you saw how the air pressure crushed the balloon, crushed the bottle. Let's look at this. So this heavy aluminum plate, I can pick it up really easily because the air pressure that crushed that bottle is also holding the bell jar onto the base plate. So that's why I can do that so easily. Okay, so now let's stop this and let the air back in. Okay, so I can let the air back in. I'm going to turn the pump off briefly so I can make it a little quieter. Okay, so that, now you'll notice it comes right off.